Yes, class. Good evening.
Good evening, ma'am.
In the last class, we had started with rotational motion. Yes, in the last class, Abdullah, I've received your doubts. I'll discuss it in the class only. I have received your doubts.
Okay, ma'am.
Now, see, rotational motion and center of mass was the topic that we had connected. So, firstly, we had seen, I'm audible to all of you. Now is the internet fine? Fine. Are you able to hear? Am I audible?
Yes, ma'am.
All right, class. So the first way topic that we did was a rigid body, a body that could not be compressed easily. So it is made up of a system of particles. Not a single particle was involved in case of rigid body. And that also we had seen it was of two types, discrete and continuous. Then a very important topic we had started with was center of mass. So center of mass is basically a point where the whole mass of the body is supposed to be concentrated. So instead of the entire system of particles, no, you can just replace the body with the center of mass, because this is a hypothetical point where you assume that the whole body is supposed to be concentrated, whole body is mass. That's why we replace the whole body instead of the with just the center of mass. So formula we had seen, R is equal to m1r1 plus m2r2 up till you can keep on adding m divided by the total mass. That is valid for x coordinate, y coordinate, z coordinate. If you have variable, then you integrate it like this. This is how you integrate. So this was how to calculate center of mass. Even if you have in Cartesian form, even if you have in polar form, this way you can complete it. Now, we'll continue with center of mass only. Center of mass is a big topic. Let us complete with that. You have to understand motion of center of mass. In the last class, we had just studied the fact that what happens to the center of mass, or how do we calculate the center of mass. But see, when the body is in motion, let's say this is the body, this body is in motion. So the center of mass that is present, that will also be in motion. Whatever is the center of mass that is present, that will also be in motion. So it means, for example, let me take the same example, same graph. So again, some point M1 separated by R1, another point M2 separated by R2, and so on up till Mn separated by Rn. Now what additional part that I am considering is the velocity. This is having velocity V1, this is having velocity V2, this is having velocity Vn. N, why? Because of the nth. So this is not 2, this is n. Like this. So masses are present. So till now, before the introduction of velocity, how did we write the center of masses formula? M1 into R1 plus M2 into R2 plus M3 into R3 plus M4 into R4 divided by M1 plus M2 plus M3 plus M4, M5, and so on. This way we write it, right? Now what are we calculating? We are calculating the velocity of the center of mass. So see, position of center of mass was what? I hope you all have revised this. If you have any doubts, those who have revised, you can ask from center of mass. So plus Mn Rn divided by the total mass. Let's say capital M is the total mass. Suppose, let's say total mass is capital M. Now, if the system is in motion, then position of each mass will change. So see, if this is RCM, how do we calculate velocity of center of mass? If you have position and you want to find out velocity, velocity is differentiation of position with respect to time. It means we have to differentiate this entire term. You are differentiating what? D over dt of what? This entire term, M1 R1 plus M2 R2 up till Mn Rn divided by M. differentiation of this entire term. Now see, we have already discussed that whenever a constant term is there, that constant term is kept out of the bracket. Right, this constant term is kept out of the bracket. So 1 by m is there. Now what is left? m1 dr1 by dt plus m2 dr2 by dt, right? This capital M, I have taken it out here. Now what is left? This will be left up till mn drn over dt. Again, class, what is dr1 over dt? That gives you the individual velocity, no? Change in position of this velocity. So this means VCM will be 1 by m will be there. m1 v1 plus m2 v2 up till mn vn. From where did this v arise? How did I write this? See, r1 by dt is v1. You will write v1 as dr1 by dt only, no? Rate of change of position, rate of change of displacement, dr1 over dt. Similarly, dr2 over dt, like this you write. So that's why m1 v1 plus m2 v2, like this also we can write. So class, this is one formula that you can use. This is one of the final formula that we use for calculation of velocity. Just a second. So this is the formula for the velocity. Velocity of center of mass. Now, some other thing also you can calculate. From position, you calculated velocity. If you know displacement, if you know position, you can easily calculate velocity. Now, if you know velocity, you can also calculate acceleration or not. How can we calculate acceleration if VCM is known to us? See, when position was known, RCM was known, we calculated VCM. Now VCM is known. It means acceleration can be calculated. So see, acceleration will be d VCM over dt. Fine. Rate of change of velocity over dt. Now this will become 1 by m. The m1 v1 over dt, same things, plus d m2 v2 over dt up till d mn vn over dt, like this. So again, 1 by m you can take common. See, from here again, dt, dv1 over dt. From here also, no, we can write this as, it's better if we take mass out, because mass is a constant term. So mass out, then differentiating this. Like this. Now see, dv over dt. This is acceleration 1. dv over dt, dv2 over dt, that is acceleration 2. So same formula we are obtaining in terms of acceleration as well. That is m1 a1 plus m2 a2 plus up till mn a. Fine, this is the acceleration of center of mass. So same thing, no? Did you notice when we had position, we used m1 r1 plus m2 r2 plus m3 r3 divided by total mass. When we are having velocity, we are using m1 v1 plus m2 v2 plus mvn divided by total mass. When we are having acceleration, m1 a1 m2 a1 divided by total mass. So formulas are same, just you have the term that is different, right? Rest of the things are same. Now see, one more thing. When we had this equation of VCM, 1 by m as m1 v1 plus m2 v2 up till mn vn, this when we wrote this. Class, one more thing. See, m1 v1 is the formula of momentum one also. No, momentum is what? Product of mass and velocity. This is what? This is momentum 2. This is nth momentum. So it means if you multiply mass into velocity, you get m1 v1 plus m2 v2 up till mn vn. Vn. mn vn. Now see class, from here m into vcm, that it means mass, total mass of the system multiplied by velocity of center of mass. So mass into velocity will give you the total momentum of center of mass, which will be equal to P1 plus P2 up till Pnth. Like this will be the total momentum of center of mass. Fine. Now note all these points. These are the formulas for center of mass apart from your position only. Okay, class. Now this pulley mass system is given. So pulley mass system we have discussed when we were doing laws of motion, how to calculate the net acceleration. So net acceleration's best method is to write the net unbalanced force. Those who were not present during that time, please revise from here. Net unbalanced force divided by the total mass that is present. So see, this is 10g and this is 5g, that is mass into acceleration due to gravity becomes the weight. So unbalanced force means 10g minus 5g divided by total mass. Total mass is 10 plus 5. So this becomes g by 3. Now this is acceleration of each, g by 3. So for this one, for this body, just a second. For this body, first one, M1, let's say this is M1, this is M2. For M1, acceleration is upwards, and upwards I have taken, this is given as negative. So it means acceleration 1 will become minus g by 3 and acceleration 2 will become plus g by 3. Now for acceleration of center of mass, what was the formula that we had seen? Acceleration of center of mass will be M1 A1 plus M2 A2 divided by M1 plus M2. So M1, first mass is what? First mass is 5 kg. Acceleration 1. This is minus g by 3 multiplied by 10 into plus g by 3 divided by total mass, that is 15. So this becomes minus 5g by 3 multiplied by 10g by 3 divided by 15. So from here you will get g. This will become 9. 15 gets cancelled. So you have g by 9. And this is acceleration of center of mass. All right. Now see one more question. Let's do. Okay, or do one thing. Note this question down. Then we'll discuss one more question. All right. Now see, this question says that 2 kg mass is given to you, 5 kg is given. So velocity of 2 kg is 5 meter per second. One direction, that is from left to right, is given to you as positive. So see, formula of VCM is what? M1 V1 plus M2 V2 divided by M1 plus M2. So let's say M1 is this mass. Let's say this is M1 and let's say this is M2. So if this is 2 kg, what will be the velocity? Yes, Aram. What will be V1 that I should write over here?
5.
5. Exactly. Good. This is 5 meter per second. Plus M2. Yes, Tarif. What should we write? M2? Yes, first mass was 2
Miss,
kg. Second mass is
5 kg.
5 kg. Good. Second mass is 5 kg. Multiplied by. Yes, Abdullah, what is the V2's value that I should write? Second velocity? Yes, V2's value, Abdullah. Look in the figure.
2, 5.
5 is the velocity. 5 is the mass. Here, this is the mass, 5 kg. What is the velocity that I should write?
2.
Okay. Tareem, same answer?
Yes, ma'am. The velocity will be 2.
True. Talha, same answer?
Yes, ma'am.
Waziha? Anyone who has a different answer?
Yeah, it would be -2 because it's in the
-2.
opposite.
Yes, Aram. Good. See, class, 2 is fine. That is the magnitude. But see, we have to keep in mind the sign conventions. You are considering vector quantity. So this will be -2. Yes, now 5 plus 2. So see, 5 into 2 minus, that will become 0 straight away. So it means center of mass won't change. Wherever will be the center of mass, it won't change its value. Fine, note this down. Okay, class. See, one concept I had discussed with you, that was internal and external forces. So see, external and internal forces, before we start with that, see, system, you should understand what is meant by system. Now, just this is left, force on center of mass. See, for forces, you should understand that forces are of two types. There are internal forces that are applied in your system, and there are external forces. Now see, what is meant by internal forces? Internal forces means the forces that act within the system. In the system can be anything that you choose by yourself. That is internal forces. Forces that are applied they are applied by the agencies of the system, within the system. Applied by agencies of the system. Fine, they are applied by the agencies of the system. Then you have external forces. These are the internal. Then you have external forces. These are applied out of the system. But what is your system? Are we just saying solar system as a system? No, any object, anything that you're considering that time. For example, right now, I'm just talking about Earth plus Moon. That's it. So Earth plus Moon, this becomes what? This becomes my system right now. And everything that is present in this universe, apart from this Earth and Moon, that will become external for me. Right now, my system, because I am considering Earth and Moon only. So this is my system. It means whatever forces Earth will generate on Moon, these will be internal forces. Whatever forces Moon will generate on Earth, that will be internal forces. If I say Sun exerts certain forces on Earth, so this becomes external force, because this is not a part of your system right now. Even if you take it on a very small scale, let's take a very small scale, let's say a glass is kept. Fine, a glass is kept on a table. Now see, if a glass is kept on a table, so what will be according to you? According to you, if you just have a look at this, so let's say certain forces are applied over here. Normal reaction is applied, weight of the glass act. So now my glass and let's say water is filled. So glass and water, this is my system right now. Now, anything else apart from this disturbs my system. This is my system. So anything in this universe, even if a hefty planet like Jupiter you consider, no, that will also be external for me. That will not be a part of system. Fine. So see, this is my system. So if I say external force has been applied, I have pushed this glass. Let's say even with the slightest touch of finger, even if you push it, this force becomes external. But these forces are your internal forces. So you should have a difference and understanding of what is meant by internal and external forces. Now, how does it affect your center of mass? See, when the individual particles, they are affected by internal forces, but internal forces, these affect the system of particles. Fine, particles of system can come into motion because of internal forces. They can change their position. Anything can happen due to internal force, but internal force cannot affect center of mass. This always remember, it cannot affect center of mass. But if you have external force available in your system, so it will definitely, external force will change your system of particles, motions, or whatever it is. But it can affect center of mass. So both system of particles as well as individual particles as well as center of masses motion also can get affected. Fine, this was a basic thing that you should know. Now derivation is what? You don't have such derivations in center of mass, and I don't think so in your school exam also. Nobody is going to ask you the derivation. Just have a look. By chance in any school it comes, so you should be prepared, otherwise it won't come. Now see, same thing, you had acceleration of mass, acceleration of center of mass, m1 a1 plus m2 a2 up till mn an, you had it divided by m1 plus m2 plus total mass that is present. So force, if you, this is what? This is the total mass. So it means acceleration of center of mass multiplied by force. I can write it right? Mass into acceleration of center of mass. Now m1a1 plus m2a2 plus mn an. This I can write. Now this becomes the force of center of mass. So this becomes F1 plus F2 up till Fn I have, right? Now these are what? If I'm talking about the internal forces, so internal forces become zero. The net internal forces of the system is zero because all the forces cancel each other. So it means this force that is acting on the center of mass, this is actually the external force because internal force will cancel each other. So this means F external's formula, this is mass into acceleration of center of mass. So normal F is equal to MA you use, same thing. So remember, always acceleration depends on only external force. It does not depend on the internal force. One man-Planck system is a very, very common question that usually comes in most of the exams in most of the schools. That let's discuss man-Planck system. One river man-Planck system is there. Note this down, then I'll write down the question. See class, understand this question. This is an important question. Please mark this as an important question. This has come a lot. This question's modification even comes in your entrances after class 12th also. Though it's not very difficult, just to understand the basic things so that any question that comes like this, you can. Now, see. A man of mass M stands on a wooden plank of mass capital M. So this is a plank whose mass is capital M, man's mass is M. Floating on a river near its bank. This is the first case. Now man starts walking. So if the man starts walking on this, so he'll reach this end. This will be the end when the man will reach. So as soon as he reaches this end, now the plank shifts a distance from where it was towards the left side. So when the man reaches the end of the plank, how much distance has the plank moved? Now class, one thing before you start with any of this thing. Man plus this plank is your system right now. So anything that is apart from man plus plank, that is your water present for the river, anything that will not be considered. Now see, first let us calculate the center of mass of the initial case. Fine, initial case. So L is the length of the plank. This is actually a part of question. Length L was given. So see, if length L is given, center of mass will be at the center. This will be L by 2. This part will be L by 2. And let's say this is the origin, x equals to 0. So see, for the first case, now for this part, M1 will be M, mass of the man. X1 will be this complete length from the origin, that is L. M2 will be mass of plank. And the length of the center of mass of plank is where? Located at L by 2. So you can calculate the initial center of mass easily using this, right? Fine. This is simple. If you put it in this formula, no, for the formula of center of mass that you have, XCM will be what? M into L plus capital M into L by 2 divided by M plus M. Right? This is it. Now see, when man reaches the other end of the plank, then coordinates of center of mass will be something different. Right? This is, let's say, this separation. Let's say this center of mass has shifted. Let's say this is the center of mass right now. This was the initial center of mass. Let's say this is now the center of mass that is present. Let's say this distance is something. This is this distance. Let's say x prime. And this distance is x, which we have to calculate how much shift has occurred in the plank. Right, and this is x equals to 0, the origin. Length will still be length will still be L. L is still the length. Now see, coordinates change. Now what will we write for the coordinate for the second case? See, for the second case, masses will remain. Fine, masses will remain the same. M1 will be small m. M2 will be capital M. Now x1 will be what? X1. So see, x1 will be this distance. The length will be, for the plank, the length will be x only. Right? Sorry, for the man. Because the man is where? Man is at the edge. So from the origin, how much separation has the man achieved? X only. So x1 will be x. But now center of mass is what? Center of mass is x dash. And what is this x dash? C class, you have to understand what is this x dash that is present. This is, see, center of mass has shifted, but center of mass, I have drawn it a little side. It is at the center of the plank. No. See, this is at the center of plank. Right. Now it has shifted from this position. It has arisen to this position, but now this shift has arrived, but though it will be at the center only. It means this length is L by 2. So if this length is L by 2, so this entire x2 dash will become what? X dash. This will become x plus L by 2. See, this is x dash. Now x dash will become what? L by 2 plus x. So x2 becomes x plus L by 2. Now you again use the formula for center of mass. X dash cm, take it. So m into x plus m into x plus L by 2 by m plus m. Now see class, center of mass will not change. Center of mass conservation will be there. It means, though this is in the diagram, I couldn't draw it properly. That's what I was trying to tell you. See, the center of mass is position, no? That was initially present, that is finally present. Ultimately, center of mass will remain the same. Center of mass conserves whenever, because this is because of the internal forces. So it's not very visible in the diagram, but I'll do conservation of center of mass separately then. There you can notice it. I'll do question on center of conservation of center of mass. See, center of mass will be conserved because there are no external forces that are occurring in the system. Did you notice any external force? The Planck man was a system. No external force was present. It means you can equate xcm to x dash cm. That means ml plus ml by 2 by m plus l is equal to mx plus mx by L by 2 by m plus m. This cancels this. Now we just have to find out the value of x. Now this is not difficult. Easy. See, ml plus ml by 2 is equal to mx plus ml by 2. Again, this ml by 2 gets cancelled. And from here, you can take x common. So this becomes m plus m. And from here, you have ml plus m. Ml just m, right? This has been deleted. This is now cancelled. So x is what? X comes out to be small m into capital L, small m plus capital M. I'll tell you, right now only I'll tell you conservation of momentum of center of mass, then you'll be able to relate it better. Note it down, then I'll explain you the reason behind why did we equate it. Note it down, note down the solution. Question you all have written? Question all of you have written, or do you want to see the question, anyone? All have written, then I am assuming. Fine, then note down the solution. See class, conservation of momentum of center of mass, I was saying. No. See, that is the reason why we did all these steps. Conservation of momentum of center of mass. See, momentum center of mass, what did we write just now? P1 plus P2 up till Pn. See, external force on the system. Newton's second law, force is what? Rate of change of momentum. So external force will be rate of change of center of mass. Always remember, for isolated system, this means external force is zero. Isolated system means no other force is acting. Like man plank we are talking, so it is man plank only, no other force is acting. It means the rate of change of momentum will be zero. So anything's rate that is not changing, the quantity is not changing, it means it is constant. So that's why when the external force was not present in our system, the momentum became constant, and that's why we equated all the things that were present. This is the reason, because external force is not present, therefore momentum becomes linear. One very easy question is there based on a conservation of momentum. Let me write it down. Till the time you all note it down first. Note down this point, then I'll write it. Very small question. Just means the solution is very small. Similarly, based on just conservation of momentum. See, the question basically says that a flat car of mass m is there. Let's say the car's mass is m. There's a car whose mass is m. This rests on a frictionless floor with a child of mass m. So child's mass is m. Fine. Now, if the child jumps off, if the child jumps off the car towards right with a velocity of, let's say, u with respect to ground. It means this is the normal velocity, relative velocity we are not calculating. So find the velocity of the car after the jump. See class, this question is easy. See, this is the initial condition. Initially, it is at rest. It is given that this is at rest. So initial momentum will be mass into velocity. That will be 0. Initial momentum of center of mass will be 0. Now class, when the vehicle is there, the car is there of mass m, child moves, child jumps with velocity u. Let's say velocity of the car is vc. Let's say that we have to calculate. Now final momentum of center of mass will be what? See, mu. And since this velocity is in opposite direction, so minus capital MVC. Right, mu, mass into velocity of the child, minus mass into velocity of what? The car. Mass of the car into velocity of car. Now see, momentum will always be conserved. If momentum is conserved, so this means initial will be equal to final. So mu minus mvc is equal to 0. Vc will be mu by capital. So like this only, if you're getting questions based on conservation of momentum, like this your answers will be. So I think every part of center of mass we have covered. The removing part also we did. If a disk is cut, that part also we have covered. Force, velocity, acceleration, everything. So class, this completes with the center of mass. We just have directly rotational motion equations, kinematic equations. So every one of you, those who have studied with me or those who have not, revise the equations of kinematic. 3 equations are there, no? S is equal to ut plus half at square, v is equal to u plus at, v square minus u square is equal to 2as. Those equations in terms of rotational we use in the next class. So note it down, text me done. I'll stop the class then. All those who have completed, you all can leave now. We'll continue this on Monday. Yes, class. On Wednesday, I'll take a very small test on center of mass. Just this topic, center of mass. Easy questions will be there from center of mass. So if you all agree, I can take the test on Wednesday. If something prior is there, then let me know on WhatsApp. Abdullah, since time is not there, I'll share the solution directly with you. Fine, Abdullah. I'll write and send you the solution. Okay, class. Thank you so much.
Thank you.